go. Number 2, what does it say? Sine of 35 is equal to cosine of blank. It tells you these are cofunctions. And if they're cofunctions, what do we know? What are the cofunction pairings? You guys can talk. Sine and cosine. Tangent and cotangent. Cosecant. Secant. We know these have to add up to 90. So sine and cosine are cofunction pairings. That's good. Sine of 35 would be equal to cosine of 90 minus 35, which gives us 55, and that is your answer. All right, true or false? Sine of 50 is greater than sine of 40. Okay, sine of 50, is it greater than the sine of 40? True or false? True. Why is it true? So what do we know about angles from 0 to 90? Remember how we made our list? Sine, cosine, tangent, cosecant, secant, cotangent. Would you say all the C's go? All right, so we learned up, down, where all the C's went down. And we went through each angle individually and pieced that together on why that happened. So in this case, from 0 to 90, sine increases, which means sine of 50 would be bigger than sine of 40. So this one is true. And let's look at another one. Let's say cosine of 20, is that greater than cosine of 70? Is that true or false? Who says true? And who says false? Okay, so that was only like 5 hands. Why is this true, Jacob?
It's true because since it goes down, the smaller number is actually bigger.
Yeah, so as the angle increases from 0 to 90, the cosine actually gets what? Getting smaller, so that means that it's like reverse logic. Excuse me. So in this case, cosine of 20 would in fact be bigger. Does that make sense? Yeah. Okay. Okay, I have Jacob up here with me. We're going to look at number 4. And we know about sine and cosine. They are what of each other?
Inverses?
No.
They go together in the group.
They go together. So like backtracking to
Sine and cosine.
backtracking to like 1 and 2. What do we call these? Look at number 1. It's a
Cofunction.
It's a cofunction. All right, they're cofunctions. What do we know about cofunctions? They add up to what?
1.
They add up to 90. So I want to take these two different angle measurements I have in here and add them up to what?
90.
Okay, so I'm going to say that I have 2 theta plus 10, so that's one angle, plus 3 theta minus, what is that, 20? And we're going to say it's equal to 90. And you're going to think of theta just as a variable, right? So 2 theta and 3 theta is what?
5 theta.
Uh-huh. And 10 minus 20 is what?
Negative 10.
Negative 10, and that's equal to 90.
So you add 10.
Add 10.
And divide by 5.
Divide by 5 gives me what?
20.
Okay, so if theta is 20, now the question becomes, what are my angles? So go back to the original problem there on number 4, which was, let me write it up top here, sine of 2 theta plus 10, and it was equal to cosine 3 theta minus 20. So when I go and plug in for theta, what do I get here on the left? What am I going to get? 2 times 20 is
40.
And, all right, so that's going to be sine of 50 is equal to, and what do we get on the other side? Cosine of
40.
40. And that should make sense, right? Cofunctions are sine and cosine. They add up to 90, so that shows you that you solved correctly for theta. Make sense? Okay. Okay, Catherine, we're going to figure out a 30-degree triangle. So what type of triangle do we look at to start this with? We want to make it into a right triangle, but before we looked at a right triangle, we made a... What kind of triangle was it?
69.
No.
Equilateral.
Equilateral. So if this is equilateral, what are all the angle measurements? Angle.
Oh, angle.
If all these sides are the same, that means all these angles are the same.
Why did you just say it?
All right, 60. They're whispering to you. All right, 60, 60, and 60. And what side measurement did we start with? What? 2. Okay. So we started with 2, 2, and 2. And you said we want to cut this in to make a 30-degree angle. And to do that, I'm going to cut this in half. So if I cut this down the middle in half, this really makes this triangle, which means this angle here would be
Still 60.
still 60. This now is a right angle. And this angle that used to be 60, we cut it in half, and now it's 30. I didn't change this 2 at all, so this stays the same. This down here was a 2, but I cut it in half, so now it's a... I cut this in half, so now it's a 1. And now how do I find this side over here? Well, yes, you know the patterns I taught it to you, but how would I actually find it? It's a right triangle.
2 squared plus 1 squared equals...
Pythagorean theorem, right?
Yeah.
All right, so I want to do leg squared plus, we'll call this x, equals hypotenuse squared, right? So this is 1 plus x squared is equal to 4. Subtract my 1 from both sides, so x squared is equal to 3. Take the square root of both sides, and we know this is now really square root of 3. And this goes back to our pattern where we learned in class 30, 1, 62. So we learned 31, 63, 2. And that's the one for the 30, 60, 90. And then for the 60-degree triangle, it's the same thing, just that you look at it in terms of the 60-degree angle, right?
Yes.
Okay. How about the 45? Do you remember how to make that?
45.
So let's get a new piece of paper. And
I remember the pattern.
so when we looked at a 45 degree, we looked at the right triangle, and we said if that's 45, that has to be 45, right? Okay. So that means if this angle and this angle are the same, that leg and that leg are the same, right? Okay, and we said 1 and 1. And there was a special rule for this. You could either use Pythagorean theorem, or we know that the hypotenuse is equal to leg times radical 2, right? So this becomes radical 2. So for our 45-degree triangle, we have 1, 1, and then square root of 2. Good? Okay. Okay, a reference angle. Reference angle. How do I find a reference angle? We connect it to the nearest x what? The nearest x. So if I said, 135 degrees. 135 degrees, I start here and I roll over. This is 90. And then, so we'd say roughly that's 135. And then the reference angle, we connect it straight down. So if this is 135, my reference angle is a 45. And we just talked about in the last video there, we know that 45 is what? 1, 1, square root of 2. And you go through and find whatever trig function they were looking for. Make sense? Okay.
Can you try to essentially on the packet?
Such as what?
7. Yeah.
Number, I'm sorry, what? A, so 70? All right, so if I drew, so for number 8, we'll look at letter A, 70 degrees. I would say, if this is 70 degrees, well, what's its reference angle? 70 degrees. So anything in quadrant 1, that reference angle is going to match up, right? Say we look at letter, C, 319 degrees. So if I draw 319, that's going to go 90, 180, 270. So here's 319 somewhere. And then when I connect it straight up, its reference angle would be, this is 360 up here, right? So the reference angle would be 41. Good.
So wait, we subtract from.
Just draw your angle and then connect it to the nearest x-axis, and then ask yourself, how many degrees do I need to travel to get to that x-axis?
Oh.
Good?
Yeah.
All right. Number 9. Use reference angles to find the 6 trig functions for 240 degrees. So, let's draw a grid. 240 degrees is in which quadrant? Which one? Third quadrant. So I say 90, 180. This is 240. So when I connect this back up, we knew this was 180, right? So how many degrees did I drop down? 60. So this is a 60-degree angle, right? And if that's 60, this is how many here? 30. And what's our phrase? 30, 1, 60, 3, 2. Now, I'm in quadrant 3, so what do I know about this 1 and this root 3?
Negative.
They're both going to be negative, okay? And then it says find the 6 trig functions. While you have your triangle set up, you can go find all 6, right? Rationalize where you need to. So for sine, it would be the negative of root 3 over 2, right? Remember, you're always basing it out of, excuse me, the corner angle. To find cosine, what would cosine be? Minus 1/2 tangent would be, and a negative over a negative is a positive, so it's really just root 3, and you don't need to put it over 1. And then to find the other 3, you would take these 3 and just flip them. So to answer your question, this is not calculator part. This question says sine, it's a true or false question, is the sine of 120 equal to, so we'll put a little question mark up there, is it equal to the sine of 150 minus the sine of 30? So on paper it might make sense to you because you say 150 minus 30 is 120, but so now we need to go through and do some comparisons. So we need to find these all individually. So if I want to find, and we use the reference angles like we just did, so if I want to find sine of 120, that's going to be over here, right? So this was 90, and how many more degrees did I go? 30, making this reference angle how much? So this is a 60-degree angle. So this makes this one up here 30. So 31, 63, 2. Of course, the phone is ringing. Hello? Yes, she is. Yeah, sure. Uh-huh. Kelly, LC11. Okay, continuing on. So we know 30, 1, 60, 3, 2. Okay, so I'm looking for the sine here, right? So the sine is what? Over the? So what is it? So root 3 over 2. So if we can come up with that over here, we could say this is a match. So I need to find the sine of 150. Let's draw that. If that's 150, what's my reference angle? 30. 31, 63, 2. What is the sine of 150? 1/2. So 1/2 minus. Now we need to find the sine of 30. Let's go over here. So if this is a 30-degree angle, its reference angle is still going to be the same thing, right? Quadrant 1. So 31, 63, 2. What's the sine of 30? 1/2. And so in other words, here's what we came up with. Do those equal out? So is this a true statement? I would say false statement. So if you came up with the same thing on either side, then you would have in fact true. Yes? Speak loudly so your question gets recorded here.
So when you set it up, like for the sine and stuff, you draw it, like it's like you use the reference angle for it to build the 150.
So like for the 150, I said I knew I went 150 degrees over. So when I made my reference angle, I was 30 degrees away from the x-axis. And then I go 31, 63, 2, which is what we looked at in problems 5 to 7 when we built those special right triangles. Yes?
In questions like these, are they always going to be simple ones? Like
Angles you can work with?
Yeah.
Yes. It's always going to tie into a 30, a 45, or a 60. Record. All right, we're looking at the grade resistance problem, and they give us a formula, and the formula they give us, and it'll be given to you on your exam, is F equals W times sine of theta. W is our weight of the vehicle, F is the force, and theta is the angle of either elevation or depression going up or down. So for part A, it says find the force if the car weighs 4,000 pounds. So where am I going to plug that in?
For W.
Okay, so we're going to say 4,000. We're finding the force, so we leave our F. And it tells us our angle of elevation is 2.8 degrees. So this is really sine of 2.8. So now go to your calculator. Make sure it's in degree mode. Figure out what sine of 2.8 is. 0.0488. And then take that times 4,000.
195.399.
That's all there is. Make sense?
Makes sense.
Okay. We're looking at the second, number 20, because I can't count. They give us the following picture. And what does it say? To find the distance across the lake. So our lake is over here. And we'll say L for lake. And they give you some letters. S, R, T. What else does it say in the problem? RT is 53.1, so we'll put that down here. And we know this is a right angle. And angle T is 32 degrees and 10 minutes. Angle T, so let's just write this in the corner. 32 degrees, 10 minutes. Oh, 10 minutes, Maggie, how do I turn that into degrees?
Well, you're going to divide 10 by 60.
Yep.
And then make that a decimal point, so it'd be 32.167.
32.167? Let's just call it 32 point. Yeah, that's fine. So we have an angle, and so what are we ultimately looking for? Find RS. So we're looking for this part over here, the lake. So we have a right triangle. I know one of my angles across from it, including the 90, correct? We know two angles. Oh, they give us another one? I wasn't even reading, I'm sorry. They give us an angle 57 degrees in 50 minutes. 50 minutes would be 50 out of 60, which gives us what? 0.83. And we're looking for RS. So really they gave us even more information than we needed, right? Because you only needed one of these angles and one of these side lines. So let's call this, I don't know, side L for lake. So which trig equation are we going to set up here?
We could do tangent of 32.17.
Tangent of 32.17 is equal to, and then when you think of SOHCAHTOA, the TOA tells us what?
Opposite over adjacent, so it would be L over 53.1.
Good. And how do I solve this?
Then you would multiply the tangent of 32.17
By?
by 53.1, and that would equal L.
Okay. Go ahead and do that on your calculator.
L would then equal 33.40.
33.40. Sounds good. Any questions, guys? Okay. Okay, this is number 21, the bearing problem. So what's our first sentence say here? It says, radar stations A and B run in east-west lines. Let's draw two lines that are east and west and mark A and B. And how far apart does it say they are?
4.8.
4.8. Okay. And what's the next thing? Station A detects a plane on a bearing of 64.2. And if it doesn't give us a direction, we assume it to be what?
Northeast.
Northeast. So I'm going to go north. So north, east. And we'll say that that is 64.2 degrees. Okay. And what else does it tell us? Station B simultaneously detects a plane 334 degrees. Again, no direction, so I assume it to be...
Northeast.
All right, so we're going to go 334. There's 90, 180, 270. So this angle I'm creating up here now is how many more degrees? We're going to go ahead and draw that on up. How many more degrees? This was 270 to right here, and I'm trying to hit 334. Is that a 0.2? I can't. Oh, you're right. I didn't see the 0.2. So we're trying to hit 334.2. And we already have 270, so what's 270 away from that? 64.2. We're going to assume this to be point C, and what kind of angle will this be?
Up there, right?
Right angle. And what ultimately are we trying to find in the problem? They want to find the distance from A to C, so the actual problem we're looking for is to find this part here that I'm marking off in green. So I would redraw this triangle now so that you have right angle, 4.8, A, B, C, and we're looking for X, and I know this angle down here is 64.2. Okay. How do I find X?
I can't look at the top.
Okay. Which part of the triangle is the 4.8?
The 8. Oh, the hypotenuse.
The hypotenuse. Let's put in H by P down here.
So I
So
can use
I know that angle, right? So that angle gives me the opposite and the
hypotenuse.
opposite and the hypotenuse. So which SOHCAHTOA, what trig
Sine.
function? Sine, because, so, right, opposite and hypotenuse. So we're going to say the sine of what? 64.2 is equal to what?
That's over 4.8.
x over 4.8, and then multiply both sides by,
4.8.
so 4.8 times the sine of 64.2 is going to give us our x, and what do we get?
4.32.
4.32. So this x right here, 4.32, and what's our units from? Kilometers. Make sense? Okay.
Will you take off if we don't put kilometers?
No, I will not take off, but at this point in pre-calculus, you should include your units. Make sense, guys? Okay. Okay, this is number 23. It's very similar to the problem in your book that dealt with the height of the tree. So even if you want to, you can call this here's the tree. So we're looking for h. Rodrigo, what am I doing?
Looking for h.
Got that part, yes.
All right.
What are we doing?
So I'm gonna need the tangent of 24.3.
We're going to say the tangent of 24.3, okay, is equal to what?
It's equal to the tangent of 37 degrees.
No.
It's equal to h.
H over,
over x.
that's part of it. Now,
Over
24.3,
60 plus x.
60 plus x, because this is the big triangle, right? This
Yeah.
one here is opposite over adjacent. So over 60 plus x, I agree. And how about the other triangle, this smaller one over here? What can I say about tangent?
Tangent of 37 degrees
Is equal to?
is equal to h over x.
Okay. And I want to solve both of these for what letter?
For h,
Okay, so how do I do that? I multiply both sides by?
cross multiply.
Mm-hmm.
So that one would be tangent 24.3 times 60 plus x
Is equal to?
is equal to h.
Okay, and when I come over here, I do the same thing, right?
Yeah.
And get tangent 37 times x is equal to
H.
h. Okay, and if the left stuff is equal to h and the right stuff is equal to h,
Because we know they're equal to each other.
so the left stuff has to equal the right stuff. So we can say tan 24.3 of 60 plus x is equal to tan 37 times x. Okay, what am I doing over here? I'm going to,
You would multiply.
so distribute. So, excuse me, 60,
60 times tangent of 24.3
yep.
plus tangent 24.3 x.
So let's put the x first. Is equal to, I'm just going to multiply these and get x tan 37. Okay, what do I want to do next? I want to
Subtract.
get the x's on the same side. So I'm going to subtract this part right here. So 60 tan 24.3 is equal to, if I subtract that on over, this is x tan 37 minus what?
Minus x tan 24.3.
Okay. What can I pull out from over here?
You can pull out an x.
Okay. So this is 60 tan 24.3 is equal to x times the quantity of
Tangent 37 minus tangent of 24.3.
tangent of 37 minus the tangent of 24.3. I'm trying to solve this for x, so what do I do to both sides?
So you divide by the stuff in the parentheses.
Stuff in the parentheses, and when I divide that over here, this is going to be 60 tan 24.3 divided by tan 37 minus tan 24.3. Somebody at the calculator, do this, please.
Is that the only way to do that problem?
There were other ways, I'm sure. Say that again, Maggie. 74. 745. Okay, so if that's equal to x, that's that part right there. So in reality, let's redraw our triangle. This angle is 24.3. There's h, and if this x is 74 point something, that's going to give me what? When I add the 60 to it, 134. Let's just use one decimal. 0.7. Okay, and then I want to find h. So which trig function are we using here?
Opposite of adjacent.
Which is
Tangent.
good. So tangent of 24.3 is equal to h over, running out of room here, 134.7. Multiply both sides by my 134.7 times tan 24.3. What do we get? Somebody?
You get 60.84.
60.84, and we will roughly call that the height of our tree. Make sense?
Yep.
Okay. Okay, we used the wrong numbers on that last problem. So while the problem is set up correctly, plug in the actual tangent values of those angles and go back through with your calculator to verify the correct answer. The math is correct. When one of our students plugged in the tangent values, she elected to use the wrong numbers. Thank you. Okay, guys, that's all we have for the trig review. Hopefully this helps you, and good luck. I'll see you Monday.